All right, so let's do example 1 of our notes together. So 2 cyclists start at the same time from opposite ends of a course that's 45 miles long. So they start at the same time, and they're at opposite ends of the course. So that means one of them is going to go one distance, one of them is going to go the other, and we're trying to find out when they meet. We know that the course is 45 miles long, or the total distance is going to be 45. One cyclist is riding at a rate of 14 miles per hour. The other cyclist is riding at a rate of 16 miles per hour. How long after they begin will they meet? So we're trying to find t. T is what we're trying to find. So we're just going to use the variable t. Okay. So cyclist number 1, let's see, they're traveling at 14 miles per hour, and cyclist number 2 is traveling at 16. So the distance, 14t for cyclist 1, or 16t is cyclist 2. So let's get an idea of what they're doing here. The first person is on a bike. Don't judge my drawing, I'm sick, so this is what you're going to get. Going this direction, the other person, it doesn't even look like a bike, is going this direction. We need to figure out when they're going to meet. We know that the total distance, that means the distance of the first rider plus the distance of the second rider, must equal 45. So the distance of the first, which is 14t, plus the distance of the second, has to equal the 45 miles. So then I have 30t equals 45. Divide both sides by 30, and I find out that t equals 1.5. So that means that they will meet in an hour and 30 minutes, or t equals 1.5 hours. Okay, example 2. A boat travels for 3 hours with a current of 3 miles per hour. So this is the time, 3 hours. It then returns the same distance against the current for 4 hours. What is the speed of the boat in calm water, and how far did the boat travel one way? So let's talk about the time. With the current, the boat traveled for 3 hours, and against the current, the boat traveled for 4 hours. Let's see, the rate. We know that the speed of the boat is 3 miles per hour plus the current. So 3 plus W. We know, here, wait, the speed of the current is 3. Let me fix that. I want to use the variable B. The speed of the boat plus the speed of the water. The speed of the water is 3. But on the way back, it's going to be the speed of the boat going against the current minus the speed of the water, because they're fighting against each other. So the distance for the boat with the current is 3 times the quantity B plus 3. The distance against the current is 4 times the quantity B minus 3. So these boats are traveling in opposite directions. One's going upstream and then it's turning around and going back. So it's kind of a to and from, which means that the distances are equal. So that means that 3 times the quantity B plus 3 equals 4 times the quantity B minus 3. So we're going to distribute. 3B plus 9 equals 4B minus 12. Subtract 3B from both sides and add 12. I find out that B equals 21. That means that the speed of the boat is the boat is traveling at 21 miles per hour in calm water. How far did the boat travel one way? What is the distance? Well, we just plug B in. So 3 times 21 plus 3, which is 3 times 24, or 72 miles. So the boat traveled 72 miles one way. personal aircraft traveling with the wind flies 520 miles in 4 hours. On the return trip, the airplane takes 5 hours to travel the same distance. Find the speed of the aircraft in still air. So the rate, A plus W when it's going with the wind, A minus W against the wind. Time, 4 hours for with the wind, 5 hours against. So I have 4 times the quantity A plus W for my distance, and 5 times the quantity A minus W for my distance. So this one, we said that we knew that the distance of the airplane is 520 miles, and the distances are the same. So 4 times the quantity A plus W has to equal 520, or 5 times the quantity A minus W has to equal 520. So the first thing I'm going to do is distribute. 4A plus 4W equals 520. 5A minus 5W equals 520. Now, the only way to solve this system is using substitution. So I am going to multiply the top equation by a 5 and the bottom equation by a 4. That will allow me to cancel out, but I have to add a new page to do that. So I'm going to add a new page, but I'm going to start off right here, okay? So 5 times 4A is 20A. 5 times 4W is plus 20W equals 5 times 520 is 2,600. 4 times 5A is 20A minus 20W equals 4 times 520 is 2,080. So now I have a system, and I can use elimination. These two cancel each other out. So I have 40A equals 4,680. Divide both sides by 40. And I find out that A equals 117. A equals 117. So now I can take that A equals 117 and I can plug that back in to the original equation to find the speed of the wind. 4 times A plus W equals 520. 4 times 117 plus W equals 520. Distribute. 468 plus 4W equals 520. I find out that 4W equals 52, which means W equals 13. So this is the speed of the wind. This is the speed of the plane.